Welcome back. This is the second lesson recording for IM1, November 17th, 2020. So now we are up to card number 7 of Desmos. So here is one way to measure how well the line fits a data set. So we figured out the residual. Okay, we figured out the residual is how far is my data point away from the line of best fit. So in this case, the green dot is very much above my line of best fit. So that is why the blue dot is pretty high up here. And the green dot is about 1 unit below. So that is the reason my residual is 1 unit below and so on. Okay. So we figured out the residual that's represented by my blue dot. So you square all the residual and add up the squares. The smaller the result, the better the fit. Calculate the square of each residual and enter the table. The first one, 0.1 all squared. So this one was, for the first one, was 0.1 here because the green dot was just 0.1 point above. So that's why it's 0.1 all squared has been done for you. So we need to fill the rest. Okay, so but they have calculated the residual for me. I just need to do the 1.8 square. What is 1.8 square? That's 1.8 times 1.8. So you can pull out the calculator and you get 3.24. So I get enter 3.24 here. Okay, what is negative 1 times negative 1 squared? That is not negative 1 times 1. It's negative 1 times negative 1. So look what happens to the negative number. It became positive. 1 times 1 is 1, so it's just 1. What about 0.3, negative 0.3? Negative 0.3 times negative 0.3 is 0.09. It's positive. So 0.09 and 1.9 times 1.9. 1.9 times 1.9 is, I get 3.61. 3.61 here. And then you keep doing the rest. Okay, 1.4 times 1.4. This is negative, but look what happens to negative. Negative times negative is positive, so that goes away and it becomes 1.96. Okay, I lost my graph, so I had to redo the calculations. So the numbers might be slightly different than what I had before. Okay, so look what happens when you square this. Okay, square the residual. All the numbers are positive. Okay, because negative times negative is square positive. So what actually happened? The residuals could be positive or negative depending on whether it's above or below. The data point is above or below the line of best fit. But what we really care about is how far the line of best fit is from each of the data points. So we actually don't want it to be positive and negative because we don't want it to cancel out just because there's one point that is really far above and there is another point that is really far below. We don't want those things to cancel each other out, but in fact, we want those things to be added, the difference to be added. So by squaring it, the negatives become positive, and that makes it easy to add and be able to come up with how far is my line of best fit away from each of the data points. So it says calculate my sum, and that's what we have here. Great. So then let's move on to the next card. Okay. So now here we go. Drag the black points to fit a different line to the point. When you think you have the best fit line, see if your classmate has a lower sum of squared residual. Okay, so sum of squared residual. So what I had before was 9.14. So well, that's pretty good. When you think you have the best line, see if any of your classmates have anything better. Your sum is the smallest in the class. Well, that's because nobody else has joined yet. Okay, so what if I try to move this a little bit? Oh, okay, that doesn't help. That actually makes it bigger. Okay, what if I try to move down here? Oh, that makes it bigger. So it looks like what I had before, 9.117, is probably the best one. Okay, I probably won't be able to reproduce it. Okay, well, I did have 9.17, but now it is gone. Okay, so maybe the closest one I have right now is 9.37. Okay, which of the purple point does that best line fit actually intersect? So right now it is between A and B. I wonder if we can fiddle around with a little bit more. Oh, 9.02. There you go. That is probably the smallest that I can do, okay? And maybe somebody else can do better. But it's between B and C, okay? So I am just going to say it's closer to C. So I'm just going to say C for now. So let's get back to our slides. So we figured out what the residual was for each of the data points, and then we squared it. That's what we did and came up with these numbers. And then we added them all up, 0 plus 3.24 plus 0.81. When I add them all up, this is going to be the number, the R squared value. That's going to tell me which line of best fit is the best. We want this to be as small as possible. The smaller the number, that means the line of best fit is fitting the data points the best. And squaring the residual gives a positive measure, and that is the reason we did that. So this comes to brings us to what is a least square regression line. Least square regression line, which is LSRL, okay, because that's kind of a mouthful to say. It measures the best fit by minimizing the residual squared sum. Okay, so previous slide said mine was 10.3, and with my Desmos exercise, I think I got down to 9. No, the slide said 10.3, and my Desmos exercise got me to 9.3 or 9.2. Okay, so but you don't want to be doing that and trying to see. We actually have tools that to find the LSRL, and the computers that do that for you, or the graphing calculator do that for you, and that's what Desmos is. It's a graphing calculator. So to do that, you are going to go to card number 9 of Desmos, and on that, you are just going to be entering Y1 with this curly tilde, and that is in your keyboard. It's on the top left corner, right next to number 1. Okay, so it's right there. Is mx1 plus b. So if you do that, look what happens. So here we go. Where there is number 2 here, click on number 2, and it's going to open up a new window. You want to type in Y and then followed by 1, and then find that curly tilde. Okay, that's going to be right next to number 1 key. It's to the left of number 1 key, so that's going to be shift there, and that's that curly thing is mx1 plus b1. What does that do? It actually gives you the line of best fit. It actually calculates for you what is indeed the line of best fit, and they have calculated the line of best fit, the R squared value to be 0.194 in this case. Okay, this is going to be, and the slope in this case, the slope for this equation is 0.183206, and the y-intercept B1 is 1.3257. So that means the equation that you see here is if I was to write this equation, it would look like y is equal to 0.183206 x. Oh, I should have started. Plus 1.3257 because this is the slope. So this is the slope and this is the y-intercept. And that's what it looks like. So Desmos has calculated that for us. Okay, that was least square regression line or LSRL. And so that's all the statistics. And let's change change for a little bit and talk about writing equation from a graph. And that's going to come handy when we're talking about LSRL. So when you hear the word, when you're told that write the equation of the line. So you're told to write the equation of this line given this graph. How do you do that? Well, we know the equation of the line is going to be in the form of y is equal to mx plus b, where m is what? M is the slope and b is the y-intercept. So to write the equation of the line, you need two pieces of information to write the equation. We need the slope and we need the y-intercept. So how do we calculate the slope? We draw a slope triangle. So in this case, I can draw slope triangle. So I am going along here and looking for points that go through the line going through both the vertical line and the horizontal line exactly. And that's going to be right here. Okay. So that's one here. Is there another one? This would be a good one too, right? So that means I just need to draw a line and I know that delta y change of rise is 1, positive 1 because it's going up, and run is positive 2 because it's going to the right. So slope is always rise over run, so that's going to be 1 over 2. And then what about y-intercept? Y-intercept, the graph is crossing at the y-axis at 2. So b is 2. Putting that together, the equation is y is equal to half x plus 2. Remember, the slope is the number that goes in front of the variable x, and the y-intercept is the 2. Okay, so if I am seeing a lot of students when I'm seeing their homework, they're missing this x. If you're missing this x and then you just write y is equal to half plus 2, you're just saying y is equal to half plus 2. What's half plus 2? That's 2.5. Okay, if this x is very, very important, so do not lose those. Okay, so now this time we're going to shift gears a little bit. And what if we're told writing equation from 2 points? So you know how to write equation from a graph. Can you do that from 2 points? So write an equation of the line that passes through the points 8, 6 and 2, negative 3. Remember, the first number is always the x value. The second number of the coordinate is the y value. So we are trying to find the equation that is going to be in the form of is equal to mx plus b. That means we still need the two pieces of information. That's the slope and the y-intercept. So how do I do that? Well, we can certainly plot those points and graph it and find the equation that way, but that's kind of tedious, right? And sometimes you're not going to have the graphing paper handy, but you want to be able to come up with the equation without having to graph. But this is also always helpful so that you can check, is my answer correct or not? Okay, does it look about right? Okay, so let me move that over. All right, so what do we need to do? Well, slope is going to be difference in the y direction over difference in the x direction. So difference in the x, y direction is going to be the second numbers are the y number. So the difference between these, so we're going to start with the first number, 3 minus minus 3 is here, which is 3 minus and minus becomes positive, so it becomes 9. 8 minus 2 is 6. So 9 divided by 6 is 3/2.